I will now discuss the electromagnetic spectrum. The electromagnetic spectrum is a continuous range of electromagnetic radiation that spans from highly frequent short wavelengths to long wavelengths with a low frequency. Electromagnetic energy is synonymous with electromagnetic waves, radiation, and light. The spectrum can be divided into 7 different parts, including gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. Humans can only detect the visible light portion of the spectrum. They can all be measured in terms of frequency, wavelength, and energy. Frequency is measured as the number of crests that pass a given point within 1 second. The crest is the peak of the wave and the trough is the low point, just like in the ocean. 1 wave or cycle per second is called a hertz. Frequency can also be measured by the number of troughs that pass a given point within 1 second. It does not matter which one you use so long as you only count the crests or you only count the troughs. Wavelength is measured as the distance between the 2 crests. Wavelength can also be measured as the distance between the 2 troughs instead of the 2 crests. Energy is measured in electron volts, which is the amount of kinetic energy required to move an electron through 1 volt potential, but that's beyond the scope of this course. Here is a cool image I found of the electromagnetic spectrum, and you can take a look at it if you're interested. I just wanted to include it because I think it's a great example. I wish it was in better quality. Light waves across the electromagnetic spectrum behave in similar ways. When a light wave encounters an object, they are either being transmitted, reflected, absorbed, refracted, polarized, diffracted, or scattered depending on the composition of the object and the wavelength of the light. Reflection occurs when light hits an object and bounces off, like a mirror. This is what allows for us to see color. Objects are the color of the wavelength within the visible portion of the spectrum that are being reflected into our eyes, while all other wavelengths are being absorbed into the objects. White objects reflect all visible wavelengths of light, while black objects absorb all visible wavelengths. That's why white objects attract the least amount of heat and black objects attract the most. Absorption occurs when a photon, or light particle, hits atoms and molecules and makes them vibrate. The more the molecules vibrate, the hotter they get. Just like the more you move, the hotter you get. The vibrations from the molecule create heat and then emit that from the object as thermal energy. Because black surfaces absorb the most light, they therefore create the most heat. Diffraction occurs when a wave bends and spreads around an obstacle, especially when a wave hits an object that's about the same size as its wavelength. Diffraction is responsible for forming rainbows. Scattering occurs when light bounces off an object in multiple directions. The amount of scattering is dependent on the wavelength of the light and the size and structure of the objects that it bounces off of. Scattering is why the sky is blue. Shorter wavelengths, like blue and purple, are scattered by nitrogen and oxygen, which comprise most of the atmosphere. Longer wavelengths, like red and yellow, more easily move throughout the atmosphere uninterrupted. The way that I think about it is to imagine that I'm running through a packed crowd in the same pattern of the different wavelengths. So here is going to be your blue and purple, and here to the right, you're going to have your red and yellow. I am much more likely to run into other people in the crowd when I'm running back and forth in a zigzag pattern than I am if I smoothly make my way through the crowd. Aerosols in the atmosphere can also scatter light, which is why sunsets are sometimes pink, orange, and red and yellow. Refraction occurs when light waves change direction as they pass from one medium to another, where the speed is different. Light travels slower in the air than in a vacuum, and even slower in water. As light travels into a different medium, the change in speed bends the light ray towards the normal boundary between the two mediums. Different wavelengths of light are slowed at different rates, which causes them to bend at different angles. Transmission is the ability of an object to allow light to move through it without absorbing or reflecting it.